Okay, question 14. Really, this is a complex problem. You're given 200 mils of hydrochloric acid in which someone's added some carbonate. So there's an excess of acid here, some carbonate added to it. You are titrating sodium hydroxide solution against what's left of the hydrochloric acid. You use these two bits of information, the amount of acid that you can calculate from here and the amount of acid remaining at this step to figure the amount of acid that's used up. Once you have done that, you can convert the amount of acid that's used via an equation to the number of moles or amount of acid, amount of sodium carbonate. Once you've got that, simply you convert that back to mass using a simple mole to mass relationship. So step 1, find initial hydrochloric acid. 200 milliliters, convert it to liters, 0.2 liters times 0.5 moles. Moles per liter equals 0.1 moles of matter that's present. Step 2, find out how much HCl you end up with. Use the old N equals CV formula again. We know that 1 mole of HCl will react with 1 sodium hydroxide, so it's a 1-to-1 ratio, we don't have to scale anything. 0.5 moles per litre of the sodium hydroxide times 0.0205 millilitres, litres. Remember, convert that 20.5 mils into 0.0205 litres so that you don't spoil your calculations. Will tell you how much is present in that particular sample or that particular aliquot. But notice we had 200 mils to start with. We've titrated 25 mils to start with at the end of it. Oh dear, we're going to have to scale it. 200 divided by 25 will tell you how many lots of this 25 were present. And we can do that. This works out to be 8, so we end up with 0.082 moles of HCl left at the end of it. So if we know we started with 0.1 mole and we ended up with 0.082 moles, we can calculate the HCl used, okay, which is 0.1 moles minus 0.082 moles, which equals 0.018 moles of HCl used. Now, we need to look at our equation to figure out how much sodium carbonate this corresponds to. So, sodium carbonate reacts with 2 moles of HCl to make water and carbon dioxide. So therefore from that we can figure the moles of sodium carbonate equals 1, its coefficient in the equation, divided by 2, the coefficient of the thing we're comparing it against, times 0.018 moles of HCl. Let's do a sanity check on that. We would expect to have less sodium carbonate than HCl, and sure, half is less of what we're given. In fact, it comes out to 0.009 moles. Step 5 is very straightforward. You've seen this one before. Once we know the moles of Na2CO3 that's left, we simply convert moles to mass. And mass equals the number of moles times the molar mass, which is equal to 0.009, which we calculated here, times the formula mass of sodium carbonate, which happens to come out as 106. So therefore this equals 0.954 grams of sodium carbonate that was added to the original 200 mils of HCl. Now that's complicated, but each of the steps is easy. It's just a question when looking at these sorts of problems through working through all of the pieces that you need to do and coming up with your final answer. And a bit of practice will help you do that. Okay, there you go.